Hello everyone and welcome to part 2 of our Angles and Triangles series. In this video we are going to talk about transversals. The first thing we'll talk about is the definition of what a transversal is. So by definition, when two lines are crossed by a third line, the third line is called a transversal. There are a lot of different situations in which a transversal could occur. For our intents and purposes here in Math 7-8, we're going to see those first two lines modeled as parallel lines, and they'll be crossed by a third line that is not parallel. So here we have two parallel lines, line M and line N. And while the picture may not be perfect, you can always check or double check to see if lines are parallel. If indeed they have these double set of arrows anywhere on the line, those are indicators or symbols that do tell us that these lines are intended to be parallel. Once these two lines are crossed by then the third line, which here we're calling line T becomes the transversal. As a result of a transversal, there are some very important angles and angle pairs that are created, and we're going to look at those next. Here we have two more lines crossed by a transversal, and you'll see that many of the angles are numbered, for example 1, 3, 4, and so on. And then also one of the angles actually has the measurement right here of 65 degrees. I'm going to go ahead and label that angle as well, just so we know which one we're talking about. We're going to call that angle number 2. Now there are a lot of different angle types and pairs that are going to be created by this transversal, but we're going to start by talking about corresponding angles. Corresponding angles lie in the same position relative to their intersection. So of course we have our two lines, which again I'm going to call line M and line N, and then the intersection caused by the transversal would be right here and right here. So when we look at each intersection, we have four angles that surrounds it. For example, at the top we have angles 1, 2, 3, and 4, where at the bottom we have angles 5, 6, 7, and 8. So it's like just two separate sets of angles that are of course found in the same picture. Corresponding angles would be, for example, like angle 1, which is in the upper left of the first intersection, and then angle 5 in the bottom intersection. In both of these, they're in the top left of their relative intersection, and that's what we're looking for here. The neat thing is that not only now do we know that angles like this are corresponding, we also need to understand that corresponding angles are congruent. We'll identify many other congruent pairs and some other important details about these angles. But again, if we knew the measure of angle 1, then we would also automatically know the measure of angle 5. In this example then, what we might also notice is that here in the first intersection at the top, we know that the measure of angle 2 is 65 degrees because that information has been given. That means that in the bottom intersection, we would know that angle 6, which corresponds to angle 2, would also be 65 degrees. What angle then do you think corresponds to angle 3 from the top intersection? Well, your options left are either angle 8 or angle 7. Which one is in the same position relative to its intersection? Of course, you probably already know, but angle 3 would be corresponding to angle 7 here at the bottom. With all of that in mind, the next thing we're going to cover are the major types of angle pairs or sets that we're going to find in the situation where we have two parallel lines crossed by a transversal. These are broken into two main groups. And these two groups will contain angles that are either congruent to each other, or the same size, or angles that are supplementary. And as a reminder from our earlier videos, supplementary simply means that they have a sum of 180 degrees. Now we've already talked about one special pair of congruent angles, and of course those are our corresponding angles. But there are three other types that we'll also talk about. And the other three are vertical angles, which we're already familiar with, and then what we call alternate interior angles and alternate exterior angles. On the other side, the supplementary angles are known as adjacent angles, which again we have some familiarity with already. Let's take a look at some examples of each of these. So here we have two more parallel lines crossed by a transversal, and first we're going to look at vertical angles. Remember that vertical angles are simply angles that are opposite of each other and congruent, and when we say opposite, we mean opposite of each other based on their intersection. So for example here, we would have angle 1 and angle 4. Those are vertical angles. They are opposite of each other based on their intersection from the transversal, which also means they're automatically congruent to one another. The same thing would be true of angles 5 and angles 8, and angles 6 and 7, and so on and so forth. You will get quite a few vertical angle pairs from two parallel lines in a transversal. Next, we have alternate interior angles. When we talk about alternate angles, please understand first of all that the alternate part of this refers to the alternate or opposite sides of the transversal itself. In this diagram, the alternate sides would be here on the left and then here on the right. Those are the two alternate sides. Of course, the diagram could be twisted one direction or another, so we'd have to keep that in mind in a variety of circumstances. When they say alternate interior, the interior part of this refers to then the parallel lines themselves. Interior meaning inside, or in this case even between. So the interior angle options in this diagram would be angles 3 and 4 and 5 and 6. Those are all of the interior angles. So when we put it all together, alternate would mean on opposite sides of the transversal, interior simply meaning between the parallel lines. So one example of alternate interior angles would be angle 3 and angle 6. Both angles are between the parallel lines, so they have checked off the interior part of the requirement, and they are on alternate sides of the transversal, one on the left and one on the right, which then of course also does mean again that they are automatically congruent to each other. Of course, the other set of alternate interior angles would be angle 5 and angle 4, both between the parallel lines and on alternate or opposite sides of the transversal. That'll lead us to alternate exterior angles, which you might already have some ideas building on already. Keeping the same ideas as before, alternate already means on either side of the transversal, but this time exterior would mean outside or not between the parallel lines. So in this case, an alternate exterior pair of angles would be angle 1 and angle 8. They are on opposite sides of the transversal itself, and then on the exterior or outside of our parallel lines. But again, because they are alternate exterior angles, because of the unique nature of the fact that the transversal crosses parallel lines, we do end up with a congruent pair again. Our last situation in regards to the supplementary category or adjacent pairs can be a little bit tricky sometimes for some students, but please keep in mind that adjacent angles are simply two angles that share a common vertex, and of course our vertex is our intersection points here. Our adjacent angles are just two angles that share a common vertex and one common side. So you're going to have to consider this diagram from several different angles, but one pair of adjacent angles here would be angle 1 and then angle 2, which is labeled as 47 degrees. Those come together to form, you can see here, line M at the bottom, meaning they are adjacent and, of course, supplementary. As we continue to twist the picture, though, we can find many other pairs. For example, if we were to twist this picture this way, or a variety of different ways, we could potentially now see that we have angles 1 and angles 3 that are adjacent. They share a common vertex there, and this one ray between them, which means that they're adjacent, and in this situation with our transversals, they are supplementary again. They add up to 180. And we can continue to twist this picture all over the place, if it's helpful to think of it that way and see the angles in a lot of different lights. But we have angles 8 and 7, which are next to each other. We have angles even 8 and 6 that could be considered supplementary as they're next to each other, because anytime we connect these two adjacent angles, because these lines were parallel and because the transversal is a straight line, all of these angles come together to be supplementary, making that unique 180-degree pair. And that's going to be a very useful piece of information as you guys move forward. Many of these diagrams take a while to get used to and some experience to really feel comfortable with, but it's important that you understand that they are split into these two categories, congruent and supplementary, and that all of these four will always result in a congruent pair of angles, while the adjacent angles always result in supplementary. Hopefully this helps you guys get started. Good luck, and I'll see you soon.